Newton's laws of motion. Now, first of all, we should know what is a force. So, force is an external effort in the form of a push or a pull which produces or tries to produce motion in the body at rest, or stops or tries to stop a moving body, or changes or tries to change the direction of the motion of a body. Now see, when you push a ball lying on the ground, it starts rolling. The force exerted by has thus produced a motion in the ball. Now however, when we push a heavy stone, it does not move. So basically, the effort made by this in this case has only tried to produce motion but has not succeeded. So basically, the word that we have used, tries to produce motion, tries to stop the body, or tries to change direction of the body, are generally for the big bodies, in which though the force is applied, but there is no such effect on the body. Okay, now the term inertia. Now, inertia of all bodies, by virtue of which inertia is basically the property of all bodies by virtue of which they cannot change their state of rest or uniform motion along a straight line on their own. That is called inertia. So basically, if a body is at rest, it continues to be at rest, and if it is moving, it continues its state of motion. Now comes the linear momentum. Now linear momentum is represented, it's a vector quantity, is represented by P and then vector. The linear momentum of a body is a quantity of motion contained in the body. It is measured by the product of the mass of the body and its velocity. So P is m into v. In this case, the P, this is the momentum, and P, this is the vector, and v, this is the vector. Now linear momentum is a vector quantity. Its direction is same as the direction of velocity. SI unit is kilogram meter per second for the momentum. Now the first law, Newton's first law. According to this law, the body continues to be in its state of rest or of uniform motion along a straight line unless it is acted upon by some external force to change the state. So that means if no net force acts on a body, then the velocity of the body cannot change, that is, the body cannot accelerate. So basically, if the body is at rest, it will continue its state of rest, or if it is moving, it will continue its state of motion. Now the second law. Now second law states that the rate of change of linear momentum of a body is directly proportional to the external force applied on the body, and its change takes place always in the direction of the force applied. That is, the net force on a body is equals to the product of mass of the body and the acceleration of the body, and the acceleration of the body. Okay, so now the third law. Now third law states that according to this law, to every action there is always equal and opposite reaction. That is, the force of action and reaction are always equal and opposite. When two bodies interact, the forces on the bodies from each other are always equal in magnitude and are in opposite in direction. So FAB is basically of minus FBA. So AB represents the force on body A due to B. BA is force on body B due to A. So this FAB is actually equals to negative of FBA. The negative sign represents it has an opposite direction. So that is the Newton's third law. Now there are types of inertia. Now what types of inertias are there? First of all, we'll discuss this, the inertia of rest. Now see, inertia of rest is, it is the inability of a body to change by itself its state of rest. That means if body is at rest, it will continue to be at rest. This means a body at rest remains at rest and cannot start moving on its own. Now, as for an example, you can take when a bus or a train starts suddenly, the passengers sitting inside, they tends to fall backward. Why? This is because the lower part of the body starts moving with the bus or train, but the upper part tries to remain at rest due to inertia of rest. Okay, now we have inertia of motion. Now, inertia of motion, as the name suggests, it is the inability of a body to change by itself its state of uniform motion. That is, a body in uniform motion can neither accelerate nor retards on its own and comes to rest. Now, for example, when a bus or a train stops suddenly, train it stops suddenly, a passenger sitting inside the train or bus tends to fall forward. Now, this is because the lower part of the body comes to rest with the bus or train, but the upper part tends to continue its motion due to the inertia of motion. Okay, now inertia of direction. Now, again, it is the inability of a body to change by itself its direction of motion. That is, a body continues to move along the same straight line unless compelled by some external force to change its direction. Now, for an example, you can consider an umbrella protect us from the rain. Now, it is based on the property of inertia of direction. The raindrops falling vertically downward cannot change their direction of motion and wet us with the umbrella on. So this is on the, like the rain which are falling, it's an, like with the rain which is falling vertically, so we are holding the umbrella vertically. That doesn't mean that the raindrops will automatically change its direction and comes to wet us. Explanation of Newton's second law. Now we all know that according to Newton's second law, the Newton's second law of motion, the rate of change of momentum, the rate of change of linear momentum of a body is directly proportional to the external force applied on the body, and this change takes place always in the direction of applied force. Now take m is the mass of the body. Now v, consider v as the velocity of the body. The linear momentum of the body is p, that is m into v. Now F is equals to, this is the external force applied on the body in the direction of motion of the body. Now dP. dP is, when the force is applied, dP is a small change of linear momentum of the body in a small time dt. Now the rate of change of linear momentum of the body is dP by dt according to Newton's second law. Now dP by dt is directly proportional to the external force applied, or external force applied is directly proportional to dP by dt, or F is equals to K dP by dt. What is K? K is the constant of proportionality. Now F is equals to what? K dP by dt. Now what we will do is that we will substitute the value of P in this equation. So let's see. Now substituting the value of P, we know that P is what? mv. So this F is equals to K d by dt of mv. Now since m is not going to change, taking the m common, this is Km dv by dt. Okay, so this force F is equals to Kma. Now in both SI and the CGS system, you know SI is the international system and CGS is centimeter gram system. The unit of force is selected such that K equals to 1. So what formulas comes out is F is equals to m into A. So this is the formula which we are deriving it from second law of motion. The direction of F is same as the direction of A, and the SI unit of force F is, you take Newton, or since this is meter, m into A, mass into acceleration, kilogram meter per second square. Now there is an important note also. The gravitational unit of force are used to express weight of a body. For example, weight of a body of mass 5 kg is 5 kgf or 5 kilogram weight. So basically 5 kg, instead of writing 5, like the weight of the body, instead of writing 5 into 9.8, we can directly express this as 5 kgf or 5 kilogram weight. Now impulse. Now impulse is the force which acts on a body for a short time are called impulsive forces. For example, you can take hitting a ball with a bat in driving a nail into a wooden block with a hammer, in firing a gun. So in all this case, we have seen the contact force is very less, means the time is very less. So the formula is impulse is equals force into time. Now, according to Newton's second law of motion, we know that F is what dp by dt, means the force, external force, is equals to the rate of change of momentum. So cross multiplying F dot dt is dp. Now, integrating both sides within the limits indicated, we get, now see how we have indicated it, 0 to t F dot dt equals p1 to p2 dp. Now see, where p1 is what? P1 is the linear momentum at time t equals to 0, and p2 they have taken as the final momentum at time t equals to t. Now, if we take FAV as the constant force during this time, or the average force, now this, after integrating it, we can write this as it is, like F will be FAV, dt will be integrated to t within limit 0 to t, this is dp will be integrated to p within limits p1 to p2. FAV t 0 to t, this becomes p, integrating within limit p1 to p2. Now see, this will become f of average is basically f of e, f average into t is p2 minus p1. So see, this what is impulse? Impulse is what? F into t, which is equals p2 minus p1. So now, what is impulse? Impulse is a vector quantity. Its direction is same as that of force. SI unit of impulse is Newton second or kilogram meter per second. As you can see, I is what? F into t. So basically, impulse is what? The change in momentum. P2 minus P1 is a change in momentum. Now, application of the concept of impulse. The first part is the cricket player lowers his hand while catching a cricket ball. Now see, if you look at this equation, FAV into T equals P2 minus P1. So now, like when a cricket player lowers his hand while catching a cricket ball to avoid injury. Now in this way he increases the time of catch. He actually lowers his hand to increase the time of catch to reduce the momentum. Now we know that impulse is force into time, change in linear momentum. Therefore the player has to apply the smaller force against the ball in order to stop it. Or you can simply understand like see, if P2 minus P1, the ball is ultimately coming to rest. So for a given ball, this change in momentum is constant. So if you take FAV into T equals to constant, so now when this will increase, automatically force will decrease. So hence less force is exerted on the hand of cricketer. Now vehicles like scooter, cars, bus, trucks are provided with shockers. Now, when these like bus, trucks, vehicles move over the uneven road, impulsive force are exerted by the road. Impulsive force means there might be some, like uneven surfaces. The function of shocker is again to increase the time of impulse. So again, when you look at this formula, if you increase the time of impulse, the force, which is in the form of a jerk given to the vehicle, the function of shocker, so I am again saying the function of shocker is to increase the time of impulse. Now this would reduce the force or the jerk experienced by the ride of the vehicle. Now again there is a question when a person falls from a certain height on a concrete floor. Now when a person falls on cemented floor or the concrete floor, actually those floors does not yield, means they don't because they are very hard, so they are not going to yield. The total change in linear momentum is produced in a very small interval of time. So actually that speed is reduced in a very small interval of time, because of which a very large force is exerted on the persons receives more injury. Now similarly, if a person falls on a heap of sand, now heap of sand, that sand actually yields, means it increases that time to stop, because of which again taking this as constant. Now if you have increased this time of stop, so automatically this will decrease, means the force which is like the force by which it hits the sand will be much smaller, hence the person is not hurt. And Newton's third law, we have seen FAB is minus of FBA. So every action there is always equal and opposite reaction. But there are certain points which shows So let's discuss the important notes. First of all, Newton's third law signifies that the force in nature always occur in pair. A single isolated force is not possible. Any agent applying a force experiences an equal force in the opposite direction. Second point. The force of action reaction acts always on different bodies. Hence, they never cancel each other. Each force produces its own effect. Third point. Newton's third law is applicable whether the bodies are at rest or they are in motion. Fourth point. Third law is applicable to all types of forces, for example, gravitational force, electric, or the magnetic force. Magnetic forces. Illustrations of Newton's third law. First of all, the book kept on the table. Now see, a book lying on the table exerts the force on the table equal to the weight of the book. This is the force of action. The table supports the book by exerting an equal force on the book. This is the force of reaction. As the system as it is at rest, the net force is obviously on them is 0. Now what happens in walking? While walking, a person presses the ground in the backward direction by his feet. The ground pushes the person in forward direction with an equal force. The component of reaction in the horizontal direction makes person moves forward. Similarly with the case of swimming. A swimmer pushes the water backward, the water pushes the swimmer forward with the same force, hence the swimmer swims. Firing from gun. Now, when a gun is fired, the bullet moves forward, action, and that's why the gun recoils backward. Flight of jet planes and rockets. Now, the burnt fuel, which appears in the form of hot and sizzling compressed gases, escapes through the nozzle in the backward direction, or you can say in the downward direction. The escaping gases just pushes the jet plane or rocket in the forward direction or in the upward direction with the same force. Hence the jet or the rocket moves. So here are some important points also. First of all, what is Newton's first law? Newton's first law defines force. Second law measures the force. And third law gives us the nature of force. Now based on the theory that we have done, now here are some examples, questions, or you can say illustrations. Now, a balloon has a mass of 10 gram in air. The air escapes from the balloon at a uniform rate with a velocity of, now they have given 5 centimeter as a velocity, 5 centimeter per second, and the balloon shrinks completely in 2.5 seconds. Okay, calculate the average force acting on the balloon. Now we have to calculate the force. First of all, what is given to us? Now what is given to us is the mass of the balloon. The mass of the balloon, which is how much? Which is 10 grams. You can take this as 10 grams. Okay, and velocity of the balloon is 5 centimeter per second. Now this is given to you, and also the air escapes from the balloon at a uniform rate with a velocity of 5 centimeter per second. So means what is given to you? This is given dm by dt. So this dm by dt is equals to 10 upon 2.5, which is equals 4 grams per second. This dm by dt is 4 grams per second. Now we have to calculate the force F. You have to calculate the force F. Okay. Now we know that capital F is equals to dp by dt. So this capital F is equals dp by dt, or the rate of change of momentum. So this is what d by dt of mv Now what is given to us? Since velocity is constant, velocity is 5 centimeter per second, which is constant. So actually we have been given dm by dt into v. Now what is dm by dt? Dm by dt is 4 grams per second. Okay. So what is F? So this F is dm by dt is 4 gram per second into 5 centimeter per second. So basically, since this is in CGS units, this will be 20 dynes. In series unit, in series system, the force of unit is dynes. Now, second, a hunter has a machine gun that fires. Hunter has a machine gun that can fire 50 grams bullets. Now, mass of bullets is 50 grams bullets with a velocity of 150 meter per second. So that is with a velocity of 150 meter per second. A 60 kg tiger springs at him with a velocity of 10 meter per second. How many bullets must the hunter fire per second into the tiger in order to stop him in his track? Now see, consider, let n be the, now with the solution, let n be the number of bullets fired in 1 second. So let n be the number of bullets in 1 second. So n be the number of bullets in n second. Now to stop the tiger in the track, see the momentum of the bullets, see the momentum of bullets, that should be equals to momentum of tiger. That should be equals to the momentum of tiger. Okay. Now for the momentum of bullets, see, you know the momentum of bullet is mass into the velocity. So but there are n number of bullets, each having mass of 50 grams. So convert this to kg. This means 10 to the power minus 3, or divided by 1000 is the same thing, into you do 150 into 150, which is the velocity of the bullet. Now this is equal to momentum of tiger. Now see, mass of tiger is 60 kg, which is given in the question, and the speed of the tiger is 10 meters per second. So now by comparing the momentum, we can calculate n. Now n will be this will be 60 into 10 divided by this whole thing, which is 50 into 10 to the power minus 3 into 150. So you solve it, this will give you 80. So he must fire 80 bullets per second. So here what we are doing, we are just comparing the momentum. Our next example, a man weighing 60 kg runs along the rail. Now a second. A man weighing 60 kg runs along the rail with a velocity of 18 km per hour. Now 18 km per hour. Okay, the mass is 60 kg. And jumps into a car of mass 1 quintal standing on the rails. Calculate the velocity with which the car will start traveling along the rails. See, here m1 is, see, first of all, the man who was traveling, taking man in mass as m1, here m1 is 60 kg. So mass is 60 kg. Now his velocity v1 is actually, his velocity v1 was 18 km per hour. Now converting this to meter per second, this will give you 5 meter per second is the man. Now m2 is the mass of that rail. m2 is how much? 1 quintal, which is equals to 100 kg. Okay, and what is v2? v2 is 0, because that rail was at rest. Now considering v, the combined velocity of both of them, that we have to find. Okay, now again applying the principle of conservation of momentum. See, what was the total momentum? Initially v2 was 0, so initial momentum we will take m1 v1 plus m2 v2. Now see, this thing will be 0 because v2 was 0, the rail was at rest. So basically initial momentum will be m1 v1 only. Now what is the final momentum? Final momentum is when the person is on the rail. So means their mass is combined. So means m1 plus m2, taking the velocity as v of that combined person on the rail. So now this m1 v1 should be equals to m1 plus m2 v. So by the conservation of momentum, m1 v1, that should be equals to m1 plus m2 of v. Now what we have to find? We have to find v. So what is v? Now v is m1 v1 upon m1 plus m2. So this equals, substituting the value, m1 is 60 into 5 upon 60 plus 100. So this v after calculation will give you 1.88 meters per second. This is the combined velocity of the person with the on the rail. Our next example, a hammer weighing 1 kg moving with the speed of 20 meter per second. So this is the initial speed, 20 meter per second, strikes the head of a nail, driving it 10 centimeter into the wall. Okay, 10 centimeter into the wall. Neglecting the mass of the nail, calculate the acceleration during the impact, the time interval during the impact, and see the impulse. So there are three parts. Okay, so first of all, what is given to us here? The mass of the nail, mass of the hammer. So m is how much? First of all, we will writing what is given to us. M is 1 kg. So 1 kg is given to us. Okay, initial velocity u is 20 meter per second, that is given to us. How much into the wall? S is basically 10 centimeter, so this is equals to 0.1 meter into the wall. Now final velocity, since the nail comes, the hammer, it's obvious that hammer will come to rest, so final velocity v, that will be 0. Okay, and we have to find the acceleration, and then we have to find the time. Okay, so now first part was the acceleration during the impact. So now using the third equation of motion, v square equals u square plus 2as. Now substituting these values, what was v? 0 square equals, what was initial velocity? 20 square plus 2, we have to find a, s is 0.1. Okay, now what will be a? The values. So a will be equals to, this is minus 400 divided by 2 into 0.1, to which is minus 2000 meter per second square. So this is the acceleration of that object. Now the second part was the time interval during the impact. Now the time interval during the impact, use the first equation of motion. So this is v equals u plus at. Now this is the first equation of motion. Now substituting the values, v is 0, this u is how much? 20, plus this is minus 2000, and this is into t. So that time comes out to be 20 by 2000, which is 1 by 100, which is 0.01 second. This is the time interval of the impact. Now C part was the impulse. So the third part, which is to be the C part, third part, impulse, is what is basically F into T. And now we know that impulse is the change in momentum. So change in momentum is mv minus mu, taking m constant, this is v minus u. Okay, what was the initial velocity? Now substituting the values, what is m? M is actually 1 kg, this is 0, this is minus, and this is 20. So this is impulse is basically minus 20 Newton second. Next example. A rocket has a mass of 2 × 10⁴ kg. Now this is the mass of rocket. Has a mass of 2 × 10⁴ kg, of which half is fuel. So means half of the mass is fuel. Assume that the fuel is consumed at a constant rate as the rocket is fired, and there is a constant upthrust. Upthrust means the upward force, which is 5 × 10⁶ Newton, which is acting always on the rocket in the upward direction. Neglecting air resistance and any possible variation of g, compute first of all the initial acceleration and the acceleration just when whole fuel is consumed. So we have to find the acceleration and the acceleration when the fuel is consumed. Okay. So first of all, here is the mass of the rocket. So first of all, the mass of rocket is mass of rocket that is 2 × 10⁴ kg. Okay, consider this as m, small m. Let this be small m, mass of the rocket. Now they are saying half of it is the fuel. So mass of fuel, you can take this as m dash, which is equals to half of 2 × 10⁴ kg, which is 10⁴ kg. 10⁴ kg. Okay, now you have upthrust, the force in the upward direction. Upthrust, that is the force in the upward direction which is actually propelling the rocket. The value of this is 5 × 10⁶ Newton. Now this is the force. Now see, the net force of the rocket in the upward direction. Okay, the net force on the rocket, which in the upward direction F, this is what? This will be upthrust, minus the weight of the rocket, which is mg. Okay, so now substituting the values, we know what was the upthrust. Upthrust was 5 × 10⁶ minus weight of the rocket is m × g. M is 2 × 10⁴ into 10, taking g as 10. Okay, so this is 2 × 10⁵, and this is 5 × 10⁶. Basically, when you solve it, you will get this as 48 × 10⁵. So this is the total force in the upward direction. So what is the acceleration? By the formula, F is equals to ma. What is the acceleration? Is F by m. What is F over here? Now F is, we have calculated 48 × 10⁵ upon m is how much? That is the initial mass of the rocket, 10⁴, which comes out to be 240 m/s². Now see, when the fuel has been completely exhausted. So means now what is the mass? Now the remaining mass of rocket. Take this as m double dash. Okay. So which is equals to m minus m dash, means mass of rocket minus the mass of the fuel, basically, which is 2 × 10⁴ minus 10⁴, which will give you 10⁴ kg is the mass of the rocket when the fuel has been completely exhausted. But the upthrust is same. So the net force on rocket in upward direction is basically will be upthrust minus the weight. Again, the upthrust is 5 × 10⁶ minus weight is m × g. Now new m is 10⁴ into 10, which is 10⁵. You solve it, you get 49 × 10⁵ is the new. Now the new force, which is the, or you can say net force, which is acting upward. So again, we know that F is equals to A into m. So A is what? F by m. Now A will be 49 into 10 to the power 5 upon 10 to the power 4, which is 490 meter per second square. So this is the acceleration when the fuel has been completely exhausted.